All telephone numbers are preceded by a 3-digit area code. In the original Bell telephone system of assigning area codes, the first digit could be any number from 2 to 9. The second digit would be 0 or 1. And the third digit could be any number except 0. So it could be 1 to 9, right? 2 to 9 is how many numbers? 8. 0 and 1, 2, 1 to 9, 9. 144. (72 times 2). Number 2. A password for a certain computer program needs to be arrangement of 4 characters consisting of letters and digits 0 to 9. So total, how many options do we have if we had no restrictions? Yes, 36. You have 10 digits, 26 letters. If the letter Y is considered to be a consonant, what is the number of 4-character passwords that either begin with a consonant or means what do we do? Add no consonants at all. So vowel, 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 right? So this one does it say anything about not repeating in there? No, so we assume we can repeat, right? The only time it doesn't have to say not repeating is with a word, correct? Because you only have those letters in that word. So we have 26 for here, and then how many for here? 36, 36, 36. So you have to remember that those can be numbers and, yep. That is totally a 21. Wasn't this yesterday when I did the same thing? And yeah. You mean there's not 26 consonants in the alphabet? Oh my goodness. I even put a C underneath and then didn't listen to myself. I'm really good at this. Vowels. How many are for the last 4 blanks? At this point, I'm not trusting myself. So is there? 15. Why? Everyone wants to put 5, 5, 5, 5 because they put vowels. But they can be vowels and numbers, right? The only restriction was that it couldn't be consonants. So it's 15, 15, 15. Whoever did this, which one did you get? The biggest one? 1,030,401? 401? Don't say 401. That's so bad. The elementary teachers will take you down if you say and one. You don't put an and in there. So I have to stop myself because I do it badly. An illegal math move. Once again, you get a math ticket in elementary to pay it back with Smarties. I have no idea. Smarties are nut-free. Yep, Smarties. Okay. An airline company. Ooh, you guys should have to pay me since I stopped coffee now. You should get to coffee. You should have to pay me in with math tickets because I don't want money. I want to pay me with sparkling water. How sad is that? A juju. I don't know. I want to tell a story, so I want to pause this. Where's the thing? And we're back. An airline company requires flight attendants to wear a pair of pants, a shirt, a tie, and a blazer. I'm glad they require them to wear things. That's good. The flight attendants have a choice of 3 different pairs of pants, 5 different shirts, 4 different ties, and 2 different blazers. Now, they're just wearing one of each, right? And if they wear one of each, we can use fundamental counting principle, correct? So the maximum number of different outfits a flight attendant could create using the items provided are 3 times 5 times 4 times 2, which is? Yep. 6 times 20. The number of 3-digit numbers less than 400 that can be formed if the last digit must be a 4 or a 5. Now it needs to be a 3-digit number, so we know that the first digit can't be a 0, and the back has to be a 4 or 5. Does it say anything about can't repeat? No, so we assume you can. We don't have to box and hold. We have two options for here. Here we have what? 1, 2, 3, because it has to be less than 400, right? And then this could be 0 to 9. 1 to 3 is how many options? 0 to 9 is how many options? The answer is 60. Numeric response filling left to right, like you read. And half you're going to get wrong. You all smiling at each other, probably filled in right to left, didn't you?
A little bit.
Yeah. And you do not need to fill in all the boxes. It is suggested that you don't, actually. So like if it's 60, don't go 60 decimal 0. The little machine, like when your paper does this. You lay it on the machine. I'm visualizing. And then your paper goes shoo, and then it's marked. That's it. It literally goes shoo. I've heard the machine. I have not. I'm lying. But I'm sure it does. It makes a noise. Just like, oh, like your life's mark is flying through it. That's what it does. And then it marks it, it's a machine, so it's like, it will mark 60 in these boxes, right? So if you go 60 decimal 0, it's like, that doesn't match. It doesn't go, oh, that's the same. We're going to give it to them, you know? It's the same. I know. They just want to fill in all the boxes. It's totally fine. It's completely fine. I'm going to give them the mark. No, it doesn't. It just goes in its head or in the machine. I don't really know what it does, and it marks you wrong. So, please, don't fill in all the boxes unless specified to fill in all the boxes. Okay? Left to right like you read. We're going to skip number 5 for now. How many even 6-digit numbers without repetition? The moment I have even without repetition, I have to do 2 cases. To work together as a team right there. 2 cases. So this case or this case. The one case has a what at the end? A 0, and the other one has 2, 4, 6, 8. All right, so we get a 0, we have one option. When we go to here, we have 1 to 9, which is 9. And we box the 9, well, the 0 is boxed. 1, 8. Don't bring the 0 back because we used it, right? 8, 1 to 7. 7. There's 2 more in there. Why didn't I do 4? I'm so used to doing 4 from the last 2. I've literally taught that same lesson 4 days in a row. 3 days in a row. We're on the 4th day. And it's always been 4. And put some more blanks in there. Erase. Go away. 1, 2, 3, 4, 5, 6. 0. 1 to 9. 9. 1 to 8. 8. 7. 6. 5. 1. Or 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 4. Then here I have, I'm in box 8, 1 to 7 and 9, which is how many? 8. Thanks for answering. And then I have 1 to 7, which is 7, right? That is right. So what else remember to do? 0, 0 everywhere. Wave it around like you just don't care. 8. And then 1 to 7, 7, and then 6, and then 5, and then 4, and then boom, boom, boom. Right? Good times. What's that answer? A lot of 8s. Everyone agree? Beautiful number. It's way better when you do 6 blanks instead of 4 when it's a 6-digit number. It's the first step, you know? Like, do the right amount of blanks. So we're going to try that out. Okay, we're going to come back to number 5 later. So you can keep that one. Then we go to our notes. We're here. Okay, we're going to do factorial notation. Remember I told you if you can count down like a rocket, it's factorial notation. So like 6, 5, 4, 3, 2, 1, blast off, 6 factorial, right? We're going to deal with ones that are n's. Now if you look here on the formula sheet, that's near you. If you look here on the formula sheet, says permutation combinations in the binomial theorem, and I'm going to give you a formula sheet. I'm just getting them laminated. So this is going to be your formula sheet. These are going to be the ones that we're going to use this unit. Okay? Up here it says n factorial equals n minus 1, n minus 2, times 3 times 2 times 1, because we have to end at 1, right? So this would actually be this, and then 3, 2, 1. N factorial, because you're going down by 1 until you get to 1, correct? N factorial, we just happen to not know what n is. N could be 7, n could be 20, n could be whatever, right? So we're going to go through a little bit of simplification first, and then we're going to use factorials today only so that when we go to permutations, we can actually use the permutation formula, which is this one down here. There's this formula down here. Your notes seem to not have any fractions on them, which is great. I don't know why. It literally didn't print fractions. If there's a fraction in this lesson, it didn't print them, which is 90% of them. So I'll rewrite them so you can see them. So it says simplify the following expression. Leave your answer in product form. What's product? The answer to a... What operation do we do for product? Multiplication. Exactly. So we're not going to FOIL. We're not going to distribute. We're just going to leave them. Okay? Do not expand. So what we want to do is we want to get rid of the factorial symbol. So the only way we can do that is we take the largest factorial and we will expand it out so it can cancel out the smallest factorial. Okay? So is n plus 2 or n factorial bigger? Which one's bigger? If you plug something in for n, like at 6, this would be 8 factorial, this would be 6 factorial. Which one's bigger? The top one, the n plus 2, right? So if you never know which one's bigger, just plug a value in for n and then see which one's legitimately bigger, okay? So n plus 2 is bigger, so we're going to expand it out because it's going to end up being able to cancel the denominator out because it's the same. So if we start at we'll leave the denominator, so it's going to be equal to. When we have an expression and a new expression, we need to make sure we put equal to signs because this is going to equal this. It's just going to end up being the simplified form of it, but they're still equal. And that's what annoys profs the most is there's never an equal sign on a page. I'll sometimes mark a unit test and they'll have not one equal sign. I'm like, what? There's equal things. These things are equal. So this equals this. So if it's an expression and it doesn't have an equal sign, and you're simplifying it, you should be going this equals this equals this equals this, right? Because they're just the simplified versions of the original. All right. So n factorial stays the same, because I'm not doing anything with it, because it's the smaller one. N plus 2 factorial, I'm going to expand. So I'm going to get n plus 2. And then what's one less than that? N plus 1. And then what's one less than that? N. And then I could keep going, couldn't I? It would go on forever. Or I can just put a factorial symbol saying it's going on forever. Now, why can I do that? Why would I stop there, basically? Now you have one on the top, and n factorial, and one on the bottom, don't you? They match. So that's why I stopped there, because it matched the bottom, the denominator. So now I can cross them off, because it's n factorial and n factorial, and I'm left with n plus 2, n plus 1. For B, which one's bigger, n minus 2 or n minus 1? Plug 6 in for n. Which one's bigger, the top or the bottom, the numerator or the denominator? The bottom. So I plug a 6 in, this will get me 4 factorial, this will get me 5, right? So this one's the bigger one. So I keep the top. And I expand the bottom. So I'm going to get n minus 1. What's one less than that? N minus 2. Factorial. And now they match. So I can cross those off, right? Every time I cancel, I'm actually making ones. So these slash lines are actually ones. Every single time you cancel, you end up with a 1, right? So on the bottom, I have n minus 1 times 1. So I have n minus 1. And a lot of people will just give me the answer n minus 1. Is that really what this simplifies to? Nope. This simplifies to, what's on the top? A 1. So I have to write it, correct? For C, it doesn't matter which one is bigger. It matters which one has a factorial symbol, which is the top one, right? So it has n factorial. So I can only expand that one. We agree? So the bottom will stay, n minus 1. And the top is going to be n, 1 less, n minus 1. And then what people want to do is they want to go like this. Don't do this. They go factorial. So they want to put the factorial symbol, right? And then they want to cross them off. Do not do this because I'm going to be erasing it. So they go like this. If I'm left with just this, that no longer is a math symbol. That's an exclamation mark just roaming on your page. It's English. All you have is English on your page. Because the factorial symbol is only helpful if it has a number in front of it, isn't it? Because the factorial symbol literally says whatever this number is, I go from that down by 1 to 1. Correct? If I just have a factorial symbol, I have nothing. I have an exclamation mark. So I can't stop there. So I have n minus 1 on the bottom. I have n minus 1, which I want to cancel off, correct? I want to cross that off. So I have to go one more. N minus 2 factorial. And then I can cancel. Oop, I don't have an equal sign. So it equals n minus 2 factorial. Example 2 is exactly what we did, but it's equal to something, correct? So now instead of simplify, which this says simplify, why does this say simplify? Because it's not equal to anything. So at the most, the only thing you can do is make it simpler, right? If it's not equal to something, all you can do is simplify. You can make it in some way so that you can cancel stuff off, right? This one has an equal to sign, so they're not going to say simplify. When there's an equal sign in your equation, they're going to say solve every time, because they want you to solve for the variable, right? So when there's no equal sign, it's a simplifying question. When there's an equal sign, it's a solving question. And when it says solve, ultimately in the end, we need variable equals number, boxed, right? That's what we're looking for. Or no solutions, because none of them work, right? So when we're solving, in the end, on any test I give you, it doesn't matter where you are or any test you're given in math, if it says solve, we need to have variable equals number, box, right? Okay. So we know how to handle this part because we just did it above, right? Which one's bigger? N or n minus 2 factorial? N. So we're going to expand the n and we're going to keep the n minus 2 on the bottom. So when we expand n, we're going to get n minus 1, one more or less, n minus 2. Then do I just keep going? No, I can stop and put a factorial because they match, right? Last time it was a simplifying, so I had an equal sign here, correct? Because I was simplifying, that equaled this. Do I put the equal sign in the front now? No, the equal sign's in the middle, correct? So it's going to stay in the middle. So here's an equal sign in the middle, it stays in the middle. If there is no equal sign, it's on your left. You need to know where you put your equal signs. And you need to not just guess and put arrows if you don't know where equal signs are. I see a lot of arrows in my day. I was actually an arrow person, because when I didn't know where to put equal sign, I put arrows too. Arrows don't mean like equals in math. But I remember arrowing, being like, sure, an arrow would look good right here. Okay? And it equals 42. And these cancel. Then we're back to grade 11. In grade 11, Well, in grade 10, let's say, when there was a linear equation, 3x plus 6 equals 7, or something like that, right? You just had to isolate the variable. You had to get x by itself and you were done, right? Then grade 11 came along. And we had like this weird brackety thing equals something. What was the first thing we had to do when we had the weird brackety thing? Distribute. So we're going to get n squared minus n equals 42. Right? So that's a quadratic, correct? Technically, because we have an n squared and an n. So we can't just isolate for n no more. We can't do that like we did in grade 10. Right? So in grade 11, you were taught a different way. When you had an n squared and another variable, you had to do what first? What was your next step? Get everything to one side and set it equal to 0 every single time, right? With linear, you just try and move everything away from that variable. You just get it all by itself, right? When it's linear. When it's quadratic, when you have a squared and another variable, you have to get everything equal to 0. Okay? Or you can't solve. You just can't. So we have n squared minus n minus 42 equals 0. And I just subtracted 42 from both sides. Then we solve by completing the square, which you're never going to choose because that's way longer. Quadratic formula, which I hope you don't choose in this case because you can factor, right? We always check for factoring first. So I'm going to go over here. I have n squared minus n minus 42 equals 0. I'm just rewriting it so I can carry down. When we factor, if we have a 1 in front of the n squared or the x squared or the m squared or whatever, the variable with the 2, right? Second degree variable. We can go right to brackets. So I know when I have a 1 in front, I can go right to brackets with an n in front. If I don't have a 1 in front, if I have a 2 or a 3, which you're not going to have in these cases, if you did, you have to decomposition. You have to replace the middle term with 2 terms, bracket them, and solve. Okay? But for these rows, just going to have a 1 in front. So you can go directly to that. Then you go, what times what equals the outsides? So what times what equals negative 42? 1 times negative 42, so negative 42. And what plus what equals the inside? So negative 1. So what multiplies to be the outside, what adds to be the inside? What's it going to be? Yes, negative 7 and 6. And I always draw the lines because then I can guarantee myself I'm right. So if I go negative 7 times 6, negative 42. Negative 7 plus 6 is negative 1, so I know I'm good. And then I can just go minus 7 plus 6. So that part actually was just grade 10. We just factored, right? That was from grade 10. Then last year in quadratics, we were taught to solve. So we had to go one more step, right? We had to set each of those equal to 0. So we go n minus 7 equals 0, n plus 6 equals 0, add 7, n equals 7, subtract 6, n equals negative 6. So I boxed them. Why do I love solving? Solving is literally the best thing in math ever gave us, was solving. Because we should literally be able to check our solving and be able to walk away being happy or just cry and try again, right? That's it. Solving, you should know, if the whole test was solving, you should know if you got 100 or not, because you can check your answers, right? So I'm going to go. I'm going to put a 7 in. So I'm going to get 7 factorial over 7 minus 2. So 7 factorial over 5 factorial, technically, right? We're going to check that. 7 factorial divided by 5 factorial is 42. So it's right. So we're good. We know that one's good. We're happy. That's not the one I want. That is the one I want. So this one's good. Yay, it's correct. Now I try minus 6. Negative 6 factorial. Can I do negative 6 factorial? Can I do a negative factorial? We started a number and we work till we get to 1, right? So negatives can't be done, right? So that negative 6 one isn't going to work in this case because we get negative 6 factorial over negative 8. So we have to circle it, put a line through it, and say it's extraneous. So you must always tell them that, hey, I got the solution. It is a solution to this equation, right? But it doesn't work. So it's extraneous. Give me the permutation formula. I'll write it here. It's NPR, the N and the R are subscripts, equals N factorial over N minus R factorial. So this is why we're going over factorial notation, because we're going to be using the NPR formula. It's for permutation. So whatever you fill in for N, you have to fill in for N here. Whatever you have for R, you have to fill in for R of the formula, basically. Okay? And then it's going to look just like we did before. So that's why we did this stuff before. All right. Next page. We're going to come back to 4 later when we do permutations. I just have it in here because it's in the factorial spot, but we're not going to do it right now. So we're going to do this one. Algebraically solve n minus 1 p2 equals 90. Keeping in mind our formula is npr equals n factorial over n minus r factorial. So we need to just change this into that, right? And then set it equal to 90, basically. So this, n minus 1, is going to go in for the n's. And this, 2, is going to go in for that r. Right? So we're going to get n minus 1 in for the n factorial. So we're going to get n minus 1 factorial over, so that's just going in for the n. And then on the bottom, we're going to get n minus 1 in for the n, minus sign, and our r is a 2 factorial, and equals 90. So we're just filling it into the formula. Remembering that you don't need to memorize the formula because it's right here on your formula sheet, right? It doesn't need to be memorized. So now we can reduce this. We can get n minus 1 factorial over n minus 3 factorial equals 90. You guys try this one. So your biggest thing you guys are going to have to remember is that you have to get it equal to 0. Because people are going to try and factor n squared minus 3n plus 2. Without moving that 90 over. It has to get equal to 0, right? Then it's going to be what times what equals negative 88. What plus what equals negative 3. And it will be negative 11 positive 8. we have two solutions, right? When we check, we always want to check back into the original question, right? Not something we've touched or changed or done anything with, because we could have made a mistake. So we want to try it back into here, n minus 1 p2. So if I try the 11, it's 11 minus 1 p2, which is 10 p2. We agree? 10 p2? So we're going to go to our calculators and type that in. We're going to go 10. And we're going to go to math, where we went yesterday. Math, arrow over, 2. P2. And we get 90, so we know we're right. Right? And then if we try negative 8, if we go negative 9 p2, once you fill the negative 8 in, it'll error us. Negative 9 p2. So the reason why that can't happen is because your n, when that formula, your n has to always be bigger than your r. So in that case, if I'm saying negative 9 p2, I'm saying n is less than r. It'd be negative 9 r p2, right? So n in that formula always has to be greater than or equal to, it can be equal to r. So this one is good. This one is extraneous. You're doing 1 and 2, so you're going to have to write them down. I'm going to